guys, and welcome to Daedalus Community. Today we're going to talk about orbits again. This is the third part of the lesson, in which I'm going to explain how to visualize an orbit. First of all, thanks a lot for your feedback, and thanks a lot for asking things in the comments. This very video was requested by one of you, so if you have any requests, you can just write down in the comments, and I'll try and be as much helpful as possible. Okay, let's start with the explanation. What do we need to visualize an orbit? We need this component here, which is called a line renderer. This component is able to render a line. So if we go game object, effects, line, we'll add a line renderer. So we have these settings here called positions. We have position 0, which is the local position of the starting point of the line, and position 1, which is the end of this segment here. We'll notice that the only thing that changes is the position on the z-axis. So if we change it, we're going to notice how the second point's position changes the length of the line. And if we move on top, we'll notice that we can even change the position on the z-axis, and we can change the position of the y-axis. This parameter here called size can be changed to any integer value we want. So like if we had 3 and we change the z value, let's say to 3, and the y to 1, we will now have 2 segments. Using this component, we can easily draw any kind of shape. I have created this script here, which is actually used to visualize the orbit. We have some parameters that we know, alpha, a, and b, and we have the line renderer here. In the start function, we assign our line renderer to the line variable here. And in the update, there's a for loop. What does this for loop do? Since I don't have time to do it on paper, I'm going to try and explain this program with an extremely powerful tool. Here we are in Paint, an extremely powerful tool. Okay, let's say we have our ellipse. So I can actually draw an ellipse, and this is an actual ellipse. In the previous videos, we've learned how to find the position of an object on the ellipse depending on its angle. From the line renderer, we know how many positions we have. So, depending on the number of positions, for example, 3 positions, we know how many positions to draw on the ellipse. If the number of positions is 3, we cannot actually draw anything because there are only 2 segments. We need at least 3 segments to create a triangle. So if we say 4, we're going to create 4 minus 1, so we're going to create 3 segments, so a triangle. So let's say 1, 2, 3, and then it closes. So there are actually 4 points, and 2 of them are in the same place. Okay, the program is now going to draw a triangle, which is a good approximation of an ellipse. So if we go for 5, we'll have 5 minus 1 segments, which is 4 segments. So the program is going to draw a rhombus like these, maybe a little bit more precise. If we go for 6, the approximation will be a pentagon, so something like these, and we will notice that we're getting closer and closer to an ellipse. So, as size tends to infinity, we're going to draw an actual ellipse. What this for loop does is pretty much what I've said. It divides line into size minus 1 segments, and it assigns the position as a times sin alpha 0 and b times cos alpha, which we know is the definition of a point on an ellipse. To divide the line into increments alpha by 360 divided by size minus 1 times these, which is needed to convert degrees to radians. We can actually see that the system works. I've just added the a position, which is 73, and I'll show you why in a moment. I'll find a random a and b. I know it's wrong. I know a should be bigger than b, but it doesn't matter right now. So if I go and play, we're gonna see the actual ellipse here. And yeah, it works as I change A and B. Okay, why 73 and not another number? Because I noticed that to have the calculations right, I need to add a multiple of 36 plus 1. If I set A and B to the same value, let's say 3 and 3, and change the values here to 4, it's gonna create a triangle, as I said, and then a square, and so on this way. And at a certain point, it starts to lose its accuracy. But so if I set like 20, there's gonna be a hole. But if I set to 37, which is 36 plus 1, and even if I set it to 73, there's not gonna be a problem, and it looks like an ellipse. So I hope you enjoyed this part. I'm going to somehow add the code in the description. Keep requesting things in the comments and even on Instagram like someone did. So let's see as soon as possible in the next part.